Hello.
Hello.
Yes, good morning. Is this your first class?
Yes, ma'am. This is demo class for me.
Okay. I'm waiting for others to join in. So,
Okay.
where from are you?
I'm from Gujarat.
Okay. Okay, we'll just wait for 2 more minutes, then we'll start, yeah?
Okay.
All right, please turn on your cameras. Mm, Is that how I pronounce your name, Jakshit, right? Hello. Can you hear me? Hello. Hello, can you hear me? Hello. Guys, can you hear me?
Yes, ma'am.
Yeah. Jakshit, can you turn on your video, please? Okay, thank you. So, what did we do yesterday?
Ma'am, chemical laws.
Okay, laws of chemical combination. At least two more laws are left, right?
Three more laws.
Oh, Avogadro, uh, Gay-Lussac's. What else? I think we did the rest. बाकी तो कर लिए थे ना.
Laws.
How many worksheets have you done, Suchita?
Almost four. And that integer type one, that was of atomic structure.
Okay. That's- Okay. Okay. Now you have Rakshit, can you hear us? Can you turn on your camera, please?
Yes, ma'am.
Gauri, you also? Okay. We have so whenever gases combine, you can write down. Whenever gases combine, they do so in fixed ratio of volumes like this. Okay. This law is for constant volumes, and this is for reactions involving gaseous reactants. So whenever gases combine, they do so in fixed ratio of volumes. Okay. Yes. Now we do Avogadro's law. Okay. Now, Avogadro's law. What does this law say? Now, this law says that when you have equal moles of gases occupying equal volumes. We had done empirical formula yesterday. We had now.
Yes, ma'am.
Because the only thing which is left in this. Yeah. So let's say you have 8 grams of hydrogen and you have 88 grams of CO2. All right. Which one will occupy equal volume? Quickly.
All occupy the same volume.
How? How many moles is this? This is 4 moles.
Oh, I
This is
thought it was helium. Sorry.
This is 2 moles. These two occupy the same volume. Rakshit, are you getting?
Yes, ma'am.
So we are almost done with this chapter. Yeah. If you have any doubts, you can definitely go and look at the videos. Yes. All right. I hope this is clear. Yes, things are clear. Yes. Okay. So kindly open up your NCRTs. There is 33rd question based on empirical formula.
In examples or back exercise.
Back exercises, beta, back exercises. This is the 33rd question. Examples, there are only 8, I think so, 8 or 9. Yeah. 33rd question, which is on a welding fuel. That one. Yes. Are you able to do this question? First. Yes, are you able to do it?
I'm doing it.
Okay. Jakshit, are you able to do it?
Ma'am, actually, I don't have my NCERT right now. I'm out of station right now.
Why don't you open it online? I'll present it to
Yes,
you.
ma'am. I'm searching right
Sorry,
now.
I'll present it to you. Please don't worry. I'll present it to you.
Okay.
Where are you right now? I can't hear you.
Actually, I'm on family trip right now.
Okay. You're from CBSE board?
Yes, ma'am.
Rejection. It's 1.34. And can you see now? I think now you'll be able to see it. 1.34, this question.
Okay.
Excuse me, ma'am.
Yes.
Ma'am, for finding the empirical formula, I'm having trouble with the calculation of the number of moles. It's not coming it's coming in decimal points. So like 0.45, 0.75, and like that.
No, then you have to divide it by the lowest number possible, right? That you have to do that.
Okay, so 0.45.
To bring it into the simplest whole number ratio, you have to divide it by the smallest number. That's what you do, right? You have when you have to find out the simplest whole number ratio. What do? You have to find out the smallest number. You have to divide all the numbers with that, right?
Okay.
Yeah. Wait, I'll give you one more question where you will find it more easier. Just hold on. Do this. Wait. If you just if you just could stop solving the question, I'll share it once again. I think do this one first, then you'll be able to do that. For example, I give you a question wherein leave the space for that. There is sodium, which is 14.3%. There is sulfur, which is 9.97%. There is hydrogen, which is 6.22%. And there is oxygen, 69.50%. And the molecular weight of the compound is 322 grams per mole. Now the question is that the entire hydrogen, you can write down, the question is the entire hydrogen amount of hydrogen is present as water. Is present as water. Okay. Then find out the empirical formula for this. First of all, you have to find out all the moles, individual moles of the atoms which are there, right? So what you should do is you can make a table. Okay, make a table. Imagine the entire amount to be 100%. Find out the moles. You know how to find out the moles, right? You have to divide by the gram atomic mass, as I told you on the first day. Divide by gram atomic mass, find out the number of moles. Tell me what that is first, okay? Let's solve this one together. Then you go on that question again, because that question is actually very good. So how much is 50? So moles are how many? Who will tell me, please? No use of calculators at all. Quickly divide and let me know.
You have 0.62.
Okay, what are the number of moles?
0.62.
And here, Jakshit, what about this sulfur? He will tell. Yes, please tell.
Ma'am, just a second.
What?
Ma'am, just a
I
second.
will do because this is very tough. I will do this for hydrogen. Gauri, you do this oxygen.
4.3.
What about this?
This one is 0.31.
0.31.
Now, which one is the least?
0.31, sir.
0.3.
So you have to divide in order to find out the simplest whole number ratio. You have to divide the whole thing by 0.31. Okay. Chaliye. Find it out. I hope Gauri now it's clear.
Yes, ma'am. I do know the methods, just the calculations in that one were getting a bit, so I thought I was maybe doing something wrong.
What is this? You tell me this, beta. ये बताओ. 4 है क्या? 4 है. नहीं 4 नहीं है. Sorry. Roughly 14. Okay. Now what you have to do now that they were saying that so now you can see here Na2S is there, but it says the entire hydrogen is used up as water. So can you see here? If entire hydrogen, all the 20 atoms are used up as water, there must be 10 water molecules to do the same. But there are 14 oxygens, so SO4.10, like this. This is how you make the formula. Jaksha, did you get that?
Yes, ma'am.
If you have to do problems like this, your maths has to be very strong. So now I hope you can go back to that problem and you can think about it. Yeah. That's why I stopped you in between two. Gauri, now it's okay, beta?
Yes, ma'am.
Chaliye, beta. Do it. I just want to finish this chapter off on a good note. And there are, Jakshit, if you like, if you see in that, I have nearly sent like nearly 5 to 7 worksheets are there now with you, है ना?
Yes,
5 to
ma'am.
7 worksheets are already there on mole concept. Please practice those, right? And please refer to the recorded lectures. Then you'll start with chapter number 2 today itself after you finish this question. I don't think any more topics are left.
Ma'am, can you again share that question, please?
Yes, Pita, yes, absolutely. I will share. Yes, yes. Yes, are you guys able to do it?
And the empirical formula is CH.
Good, very good. So C2H2 N factor in a ethyne. Correct? Good, beta. Others, please confirm.
Ma'am, the molar mass is 26 and the empirical formula would then be C2H2.
Yes, beta, answer is correct. Jakshit, you also confirm?
Yes, ma'am.
Okay, let's start with the new topic, structure pattern, right, today. So I want to know, we have to find out the charge and mass. Do you know the charge of electron?
1.6 into 10 to the power minus 19 coulomb.
Plus with the same value, 0. Okay. Mass of electron is okay. Fine. Now, first model of an atom that you knew is plum pudding model or the watermelon model. What do you know about it, beta?
But it was a sphere of positive charge and the negative charge was embedded into it like seeds in a watermelon or plums in a pudding.
Right. So the black seeds in the watermelon are what, beta? Right? And the red part is the electron, correct? Okay. So what was the biggest advantage and disadvantage of this model?
Mom, I just wanted to confirm, wasn't the red part the positive charge? Or am I remembering it wrong?
Oh, yes. It's the other way around. Yes. So atom is electrically neutral. Okay. That means number of electrons is equal to number of protons. Clearly, the neutrons were not discovered by that time, right? Now, what was the disadvantage? Yes.
Ma'am, it could not account for the stability of the atom.
How? That's the reason I want to know. See, the stability is when positive and negative charges are away from each other. Here, the electrons are embedded, right? Here, the electrons are embedded. So, disadvantages. Chemistry. And J.J. Thomson is also credited with the discovery of electrons. Okay, next, if you see, next in line, we have so Rutherford's model of an atom. Okay, this is also known as alpha ray scattering experiment. Alpha ray scattering experiment or the gold foil experiment. Now they took a gold coin. What was the reason to that? Any good reason for taking a gold coin? Gold is expensive, right? Was expensive then too. It is the most malleable metal, right? It's the most malleable metal. Okay, got it. And what are alpha particles? Can someone tell me what are alpha particles? They are doubly charged helium, right? Number of electrons are
And what is
zero.
the advantage of taking gold foil?
Beta, it is the most malleable metal. It can be beaten into thin sheets.
Okay.
Because I needed a very, very thin sheet, 100 atom thick only. That's why. Number of neutrons is 2. Why did they take alpha particle? Can anybody tell me? Why something with
Because
0 electrons?
so that there would be no repulsion or anything, 0 electrons.
There would be no attraction by the positively charged nucleus, right? Now you
Yeah.
come to think of it because of discovery of electrons, right? So
Hmm.
also Rutherford is he's known as the father of nuclear physics. Plus discovery of is credited to the discovery of proton. Fine. Please note this down. Do you know what was the source of uh, the alpha rays? Does anyone know?
Cathode rays.
Sorry, what? Sorry. What?
Cathode rays.
Cathode rays were not alpha particles, no. No.
Anode rays.
So alpha particle emitter here, you can see here, this was a heat depiction of the, it is uranium. When uranium disintegrates, right, it produces alpha particles, alpha rays. Now you can see here that there is a zinc sulfide detecting screen is made up of zinc sulfide because zinc sulfide basically it glows when a particle hits it, right? It has that property, correct? Now you can see that you can put your observation here and you have your inferences here in a table. What he observed. First observation was most of the alpha particles, they passed directly through the gold foil, right?
They went undetected.
Yeah, most of the alpha particles went right past. So inferences क्या है? What is the inference? Most of the space in the atom is empty.
Ma'am, why zinc sulfide was taken?
Because when a particle hits it, it glows. That's why. Otherwise, how would you know na, that they have passed right through the atom, right? Okay. Second is some alpha particles deviated at some angles. What does this mean?
They face repulsion.
They might have brushed past the nucleus. The only thing that can cause repulsion is the nucleus, nothing else, right? Or the positively charged, dense, positively charged space. One in 20,000. Got deflected at 180. That means they rebound. Right? They rebound. What is the meaning of something getting rebound? That means they were directly repelled by the positively charged center. Okay. Okay. Now the question here is, have you noted this down? Can I go ahead? The question I want to ask is, when a particle stably revolves, charge particle revolves around another densely charged center. What are the forces acting on? You have to find this out.
Centripetal force.
What else? Is that only centripetal force? There are other forces also. So you find out what is centripetal. What is centrifugal? Right? And some other force which is acting on it. Right? The not, the inability of Rutherford to explain this led to the failure of this theory. Okay? Because it was said that the electron, if it keeps on moving, it will, move into the nucleus eventually. So find out the forces which are acting on the nucleus and on the electron. And from tomorrow, I have a slight request. Please join on time, right? Try to join on time. Don't be late for the class. Okay, yeah? Okay. All right, then I will see you in tomorrow's class. I have to rush for my next class. Yes, Gauri, are you saying something?
No, I was just saying, yes, ma'am, I'll join on time.
Please, all of you should join on time. Okay, then I will see you in tomorrow's class. Bye, guys. Take care.
Thank you, ma'am.